Hello, good morning, students. Okay, so we are done till here, right? And what about this? We have to do this part. So, what essentially is a vector composed of? One second. Okay. So, what essentially is a vector composed of? So, vector is composed of two things. That is, hmm, where is the- so what essentially is a vector composed of? So, vector is composed of two things. One is magnitude, and the other is direction. Now, magnitude of p vectors can also be written by putting a modulo. So if you have, let's say, p vector and I put a modulus, so here's your p vector, right? And I put a modulus. So what do I get? I get, this gives me magnitude of p vector. Can also be represented by letter p, just by writing p, right? That gives you the magnitude of the p vector. That's what it is written, or simply as p. You just write p. P means it is the magnitude of p vector. And how do we get that? By putting a modulus sign. Now magnitude of a vector quantity is a scalar quantity or vector quantity? The answer is it is a scalar quantity. It's a scalar quantity. And since you have put magnitude, magnitudes are always positive. In physics, magnitude is a number with unit or without unit. So magnitude is a quantity it's not a number, it should be quantity. So in physics, magnitude is a quantity with or without unit. It is with unit. Like you have 20 Newton per second. Now this 20 Newton per second is the magnitude. In that 20 is the numerical value, while your Newton second is the unit, and together they are called magnitude. Write it down. Right? Let's go ahead. Let's see what is unit vector. So unit vector is a new type of vector. A vector whose magnitude is 1. Not 1 meter, no. Not 1 second, just 1. Symbolic representation of a unit vector. So you write P and you put a cap on it. So this cap signifies a unit vector. If you don't put a cap, it's not a unit vector. These vectors tell the dash of the vectors they are associated with. So what do they tell? Unit vectors tell direction. They tell the direction of the vector they are associated with. So they can be called directional vectors because they help in telling the direction of the vector. Right now, let's go ahead. Now vector can be written as a product of, we already saw, it can be written as product of what? Product of magnitude and direction. So let us rewrite a vector now using the fact that the direction vector is nothing but the unit vector. So let us rewrite a vector. So p vector can be written as you know, magnitude into direction. Like p is any vector, right? So this is any vector. Can be written as magnitude into direction. And what is the magnitude of p vector? Can just be written as p and direction is p cap. So p vector is equal to p into p cap. Where p is the magnitude and direction is p cap. So from here, if you want to write the value of p cap, what will p cap be equal to? So p cap can be written as equal to p vector upon p. Right? So that's another formula. If you want to find out p cap, which is the unit vector, you can find it by simply dividing p vector with p. P vector upon p gives p cap, the unit vector. Right? Now let's go ahead and let's see, write unit vector in direction of f vector. Okay, not this one. Now let's see direction vectors. So what comes on the top? here, north, here, south, west, and east. And here is northeast. Here is northwest. Between north and west, northwest. Between north and east, northeast. So what will be here? Between west and east, the west and south will be southwest. And here it will be southeast. So these are the directions. Right. Let's go ahead then. From here. Represent a force of 5 Newton acting north of east. Physics magnitude principles. In physics, magnitude is a one numbers. Okay, so next. Represent a force of 5 Newton acting 45 degree north of east. So let us say that you have this coordinate axis. And let's say this is north and this is north east, this east. Right? So there is a 5 Newton force and that is acting 45 degree north of east. So 45 degree north of east, right? Like this, 5 Newton. And you have to represent it. So that's how it is. That's the representation of the force, right? Now let us see parallel shifting. So again I ask you, what is the vector composed of? Magnitude and direct, right? Two vectors when shifted parallelly, are they still the same? So see, this is what I'm asking. Now answer this question. Let's say that there is a vector here, right? There is a vector. and I'm going to shift it parallelly. How? Well, I'm going to select it, and you see this is another vector. Can you see this is this is parallel to the other vector, right? I take and I put it, let's say here, right? Let's say here. Right? Now see that vector I put here. Is it fine? My question is, if this is a vector, what is this vector? Now you can see that the length is same, right? So I can say, since length is same, their magnitude is same. Agreed? Since length is same, their magnitude is same. Next, since direction is same, and and you can say direction is also same, right? So that is what a vector is made up of, right? Magnitude and direction, and they have the same magnitude and they have the same direction. And if you look at a vector, that is what a vector is basically made up of, right? Magnitude and direction. Those are the two things that make up a vector, and those both the things are same. Magnitude is same and direction is same. So what can you say about this? If this a vector, what will be this vector? If this new vector has got same magnitude, has got same direction, and that is what a vector is made up of, magnitude and direction, and both of them are same. So if this is a vector, this is also a vector. So what did we learn? That two vectors when shifted parallelly are still the same. The answer is a resounding yes. They are the same vectors. Right? There is no difference between two vectors, that is where one is nothing but the parallel shifting of the other vector. If that is the case, both the vectors are same. No doubt about that. Right? Now let's go ahead. If a vector is rotated by any angle which is integral multiple of 360 degrees, then the vector remains same or not? Let us say that you have a vector and it is uh, rotated by an integral multiple of 360 degrees, then the vector changes or does it remain same? Let's see that. So for that I'll again pick up a vector. Let's say this vector. Yeah, this vector. And if I rotate it by an angle of 360 degree, so let us rotate it by an angle of 360 degree. 360 means how much? I'll go like this. This 90 degree till now, right? It's 90 degree. Then I go further. How much angle I've reached, guys? 180 degree, right? But I have to go further. And I reach here. how much angle? 270 degree, and then I come back here and this is 360 degree, right? But I'm coming back to the same vector. So what do we learn? That if a vector is rotated by an angle of 360 degree or multiples of it, then the vector does change or doesn't change? The answer is it doesn't change. Because when we rotate it by 360 degree, the vector comes back to the original form, right? So the vector doesn't change at all, right? Now next, when are two vectors said to be equal? Now this vector and this vector, are these two vectors equal? And the answer is no. These two are unequal vectors because of different directions, right? And what about these two vectors? What about these two vectors? They have different magnitude, so they are also unequal vectors because different magnitude. Okay, so let's go ahead. Now, what are equal vectors? So, vectors that have the same dash and dash. So, what shall I write? Represent the force of represent the force of 5 Newton. 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 And equal vectors that have the same equal vectors that have the same magnitude and direction. Okay. So what are equal vectors? Vectors that have the same what? Same magnitude and point in the same direction. Right? And what are parallel vectors? Vectors that see parallel vectors means point in same direction, right? So direction is sure. What can you say about the magnitude? Vectors that don't necessarily vectors that don't necessarily have have the same magnitude. Right? Don't necessarily have the same magnitude, but they point in the same direction. Right? They are parallel vectors. Like example, let's say this is one vector A and this is another vector B. You see, they have the same direction, but the length are different. So magnitude might be different. Right? They are called parallel vectors. Are equal vectors parallel vectors? One second, I'll call you back. So what are you saying? Vectors that don't necessarily have the same magnitude and point in the same direction are parallel vectors. Like A vector and B vector are parallel vectors even though they have different magnitudes. Because for being parallel, magnitude is not required to be same. Now anti-parallel vectors. What are anti-parallel vectors? If you have one vector here and the other vector pointing the opposite direction, so they are anti-parallel vectors. The anti-parallel vectors have that so here we have written parallel vectors means that don't necessarily have the same magnitude but point in the same direction. What we'll write here? Vectors that don't necessarily have same magnitude but point in opposite direction are called anti-parallel vectors. Right? When two vectors are parallel, A vector and B vector, when two vectors A vector and B vector are parallel, then what can you say about A cap and B cap? So let's understand this. So let's say that you have one vector here and you have another vector here, but this vector size is less, let's say. Why it is turning? Okay, it's not what I wanted. Not exactly. Yeah, more like it. So yeah, this is what I was saying. When two vectors A and B are parallel, like you can see these guys are parallel, right? Are they not parallel? See? They are parallel, right? They're absolutely parallel, but they don't look like parallel. I don't know why. Fine. So when two vectors are parallel, like you can see these guys are parallel, call them A vector and B vector. So what can you say about A cap? A cap is a unit vector along A vector and B cap is a unit vector along B vector. Right? Now my question is, what can you say about A cap and B cap? That's the question. Can you comment on A cap and B cap? And what is it you can comment? Think about it. I'll give you 2 minutes to think about this. What can you say about A cap and B cap? So are A cap and B cap parallel? And what is the answer to this? So A cap and B cap, are they parallel? And the next question is magnitude of A cap equal to magnitude of B cap? That's another question. To answer these two questions, are A vectors and B vector are A cap and B cap parallel and is so since they're pointing in the same direction, are they parallel? The answer is yes. And is magnitude of A cap equal to magnitude of B cap? What is the answer to that? Are the magnitudes equal? The answer is yes. Since both are unit vectors. So magnitude of A cap is equal to magnitude of B cap, and that is equal to 1. Right? So from here I can write that since both magnitude and direction are same, A cap is equal to B cap. Right? In that case A cap and B cap will be equal. Now orthogonal means perpendicular unit vectors. So let us see what are perpendicular unit vectors. So let us define direction vectors that are unit vectors along the 3 coordinate axes. Like you have got x, y and z axis So there will be unit vectors along x, y and z axis, right? There will be unit vectors along that. And which unit vectors are along that? Let's see. So along the x axis you have got a unit vector I cap. So I cap is the unit vector along the x axis. Then minus I cap is the unit vector along which axis? Negative x axis. So the unit vector in this direction is minus I cap. J cap is a unit vector along y axis. This along negative x axis. Right? J cap is a unit vector along y axis. Minus j cap is a unit vector along negative y axis. K cap is a unit vector along, k cap is, okay, right now you don't need to know k cap, forget about this. Right now you just remember I and j, okay, which is along x and y. What is the magnitude of I cap? That's equal to 1, because it's a, since I cap is a unit vector. What about magnitude of minus I cap? That's also equal to 1. Why? Because minus will get cancelled, right? Because you're putting a modulus, and then you have a mod on I cap. So this, see, I'll tell you how this can be written as. This can be written as magnitude of minus 1 into magnitude of I cap. And magnitude of minus 1 is 1. Magnitude of I cap is 1. 1 into 1 is 1. Similarly, j cap magnitude is 1. Minus j cap magnitude is also 1, and so on. Right? So you can write this. Fine. So that's all for this class. In the next class, we'll talk about displacement.